Now listen to me, guys. Some of you are too slow when you are testing. You are going to have to click through this pretty fast. It's definitely doable. It's not too long. But some of you, especially like if you're doing Gaussian elimination, you just take too long. You're going to have to just keep moving. So that comes with practice, like everything else. We'll take the coat off for me. Let's get in uniform here. And let's go. Who has a question that you have found from something? Yes, Leah.
4B.
On the review sheet, 4B. On the review sheet, 4B. Solve in the method of your choice, and it has a star next to it, so that means it could be done on the calculator if you wish. Okay, so there are 3 types of television sets. Okay, how many vehicles of each type are needed to deliver the TVs? So the vehicles are vans. I'm gonna let X be vans. I'm gonna let Y be, what else is there? Small trucks. And Z can be large trucks. All right? Now, there's a method to my madness. I'm letting my variables be what the question is, right? Okay. The vans can carry 8 portables, 3 remotes, and 2 console TVs. The small trucks can do this, this, and this. Large trucks can do this. On a given day, they have 150 portables, or 115 portables. Okay? So, every X can carry 8 portables. Every Y can carry 15 portables. And every Z can carry, boy, there's so many numbers in here, maybe I should have charted this. 22. And that has to add up to 115. Would you agree with me, guys? Okay, let's do the same thing. Or no, let's see, what else do I have? I gotta do remotes. All right, so a van can do 3 remotes. Truck, small, can do 10. And a large can do 20. And that has to add up to 85. And then I need 35 consoles, so that's gonna be 2 X's. 6 Y's. And 5 Z's. All right, hopefully I got all the numbers in the right spots. There is a lot going on in that problem. Okay, now, how do you want to solve it? You have 3 equations, 3 unknowns, you have millions of options, not millions, but you have a lot of options. What do you think? I'd RREF it, right? I'd set up my augmented matrix. That's the one with all the numbers in it. So the second matrix edit, first thing it's going to want to know is, how big are you? This is 3 by 4. We're going to put them in. Second quit, second matrix math, REF. Oh, did I type in something wrong? I got decimals. You got decimals too? Okay, now, first of all, remember, you can change those into fractions. Okay, so I'm gonna go and let's just practice that. Math, frac. Okay, they're fractions. Now, in this particular problem, it doesn't make sense to have fractions. Now, sometimes it does. If X were how many pounds of potatoes do I need to buy, then it would be okay to have 1.7 pounds. I could do that. But what am I gonna have to do in this problem? Since X is the number of vans, I'm gonna have to round it, right? And round it up in order to cover all my bases. So it looks like I need 2 vans. I'm gonna need 4 small trucks and 3 large trucks just to be safe. I gotta cover all my bases. I gotta make sure I get all my TVs delivered. So I'm gonna round it up. Sammy?
Is it not possible that that's too many?
It is definitely possible. And what I would have to do, Sammy, is go back and say, okay, if I have 2 vans and 4 smalls, can I get away with just 2 large trucks instead of 3? You don't need to do that. I mean, if I were the manager of this company and I was trying to pay all these drivers, I would do that. But in terms of this problem, we don't have time to do that, so we're just gonna go with it. Okay? All right. I forgot who asked that question, but there's the way that's done. All right, Kylie?
I just had a question. If this was like, would a question like this be on the test, or would it be
Could
like,
be, absolutely.
and then would you want us to just round it like that then?
Well, again, what does it depend on?
Like if it's something that can be a fraction.
Exactly. If it's something that can't be fractional, like a van, then you're gonna have to round it.
Okay.
If it's potatoes, you can use decimals. It depends.
Did we already go through the last problem on homework 7.4?
I have no idea. The last problem on homework 7.4. Yes, we did that.
Okay.
We graphed that last time, didn't we? All right. What else?
Wait, I just had a question on it because when I was trying to do it by hand and I couldn't figure it out. But even when I put it in my calculator, it would just say like error.
Well, you're probably typing it in wrong there. I think I do remember doing that on video. Is that the one that's got 2 holes?
Yeah.
Yeah, that's on the video. Go ahead and watch it. You can get it. On the review sheet, number 1 on the review sheet, solve by graphing by hand. Now, this second one right here, there should be absolutely no question about what that looks like. What shape is the second one? It's a parabola. Y equals x squared is vertex at the origin. That's one of your BFFs. What happens when you put a -1 on it? It goes down 1. So that should be easy for you. You're just sketching it. There it is. Oh, I didn't take it down 1. It's got to go down 1. So here it is, down 1. Okay? Now, the fact that it's an inequality means there has to be some shading involved. Where do you think that's shaded? Your options are inside the parabola or
Inside.
outside.
You can test with points.
You can test with points, but if you just use your common sense, what does greater than mean? Above. Y is greater than is going to be above, so that's what's shaded right there. So that one is easy. This one, we actually talked about that, but it was in the last chapter and in a different context. It would be a circle if those 2 numbers were the same. So if you had x squared plus y squared equals 9, when you divided by 9, your equation would look like this. Would you agree with me? And the circle, that was a 9, the circle had a radius of 3, which means that in all directions, x and y, you went 3. Well, what happens when that stays a 9? That still means I'm going 3 sideways, okay? But now, that number is a 4, which means up and down, I'm only gonna go 2. Let me get a different color here. So, this way, I counted 1, 2, 3. This way, I counted 1, 2. So what shape do I get? Well, it's called an ellipse, but yeah, an oval. It's called an ellipse in math land. And where is it shaded, do you think? Your choices are inside the curve or outside. Since it's less than 1, what kind of makes sense? Inside the curve. So what's the answer to the question? The overlapped part. So that, the actual answer to the question, I think all we're doing is graphing it, right? Yeah, when it says solve, it means where's the overlap. All the points in this right here are the answer.
So sorry, I missed that part. So x squared over 9,
Mm-hmm.
is that, where does that come into play when you're
That's
how wide it
the
is?
radius sideways.
So it's like 4.5 each.
No, it's the square root, it's like a circle. If that's a 9, that means
Oh,
the radius is
sorry,
3.
Yeah,
Yeah.
just did not do that one through.
So it is, Peter said, is that a circle? And yes, it's a circle, but it's been smashed. Elongated, yeah. Okay, Lily?
Like, if the circle was moved up or down, or like just
Okay.
the origin, where would it?
Well, you do it exactly the same way. I'm not gonna do that to you because we haven't really spent time talking about these things, but it wouldn't change a thing about the shape. When you move it, everything stays the same. So if your center were up here, you would still have sideways 3 and up and down 2, just your ellipse would be sitting up here.
Would it be like +1, like?
Yes, yes, just like with anything else. Yes, it would look like, this one I moved right and up, so it's gonna look like x minus 2 squared over something plus y minus 3 squared over something. Right, that we're not going into that much depth, but yes, that's exactly what would happen. All right, Tess?
So wouldn't you have to shade below the 1? Because it's less than.
This is shaded inside the curve. This is shaded also inside the curve or above the curve.
Yeah, but what's the 1?
Huh?
What's the 1?
What one?
It's less than or equal to 1.
That's the standard form of an ellipse. Yeah, so that's always a 1. Because, I don't know, you must not have paid attention. You divide by the radius here, make that a 1. Yeah. Okay, let's not spend any more time on that. We got a lot of other fish to fry here. So what else do we have to do? Kylie?
Page 17 on the review, the chapter done.
17 on the review. Solve using Gaussian elimination. Notice there is no star. So just like you did on your quiz, you're gonna have to do this one by hand. So here we go. 1, 1, negative 2, 2. Oh wait, yeah.
Here, what'd you get on?
And 3, negative 1, 1, 1. Negative 2, negative 2, negative.
Wait, it's impossible. Yeah, you don't even know
All right, before I get too far into it, let me make sure I've got everything. Okay. Now, if I'm doing Gaussian elimination, that means I've got to get some zeros into my into my matrix, right? And the zeros are going to come from here. So start there. That's where I'm going to start. So I'm going to use that top row, multiply through by things, and add and hopefully get some zeros. So what do I need to do to get a 0 right here? That's going to be my first one I'm going to work on. So what am I going to do? I'm going to multiply the top row by negative 3. I always write the numbers down. You don't have to. Somebody said that confuses me. Okay, good. Don't write them down. But you got to add. So I'm going to add, and I get 0, negative 4, 7, and negative 5. Now I got to repeat the process, but I need that to be a 0. So this time I'll multiply the top row by 2. So that gives me 2, 2, negative 4, and 4. Uh-oh. What's that bottom row gonna be? 0, 0, 0, 0. Now, I don't know if this has happened to us by hand before, but it doesn't make any difference. This is what happened. So one more step, since it said Gaussian elimination, I need this guy to be a 1. So 1, 1, negative 2, 2 is my top row. Then how am I gonna make this a 1? Divide by negative 4. So 0, 1, negative 7 fourths, and 5 fourths. And then all these zeros. So the matrix is complete. And now it's time to get my answer.
You said it's complete, but normally wouldn't that 0 or it'd be 3, 3, wouldn't that be 1?
It should be 1.
But do we disregard it because it's 0?
No, because the definition is the first non-zero entry
Oh, okay.
is a 1. I don't have any. They're all zeros. So that is echelon 4. That's row echelon 4.
Oh, it's a echelon.
Now, I need an answer. My variables were x, y, and z. So I'm gonna start right here in the bottom, which is where you always start. Normally it says z equals 6. But this one says z equals something, anything. So then what does the next row say? Y minus 7 fourths z equals 5 fourths. Remember, this is the equals right here. So what's y? 5 fourths plus 7 fourths z. And then top row says what it said from the beginning. X plus y minus 2z equals 2. So x equals 2 minus y plus 2z. Would everybody agree with that? But y is right here. So x equals 2 minus 5 fourths minus 7 fourths z plus 2z. Remember, when you do it with regular numbers, you have to plug in your y and your z to get your x. That's what we're doing. We're plugging our y in. So x is going to equal what? What's 2 minus 5 fourths? 3 fourths. And what's negative 7 fourths plus 2?
1 fourth.
1 fourth. So now I can write my answer. So x, y, z. Okay, x is 3 fourths plus 1 fourth z. Y is 5 fourths plus 7 fourths z. And what's z?
0 plus 1 z.
0 plus 1, yeah. Now, normally, every other problem that we have done by hand, we've had this before, you need to be able to deal with this. Doesn't matter if it's by hand or with the calculator. But normally the problems we've done by hand, this has turned out to be like 1, 3. Right? And so that told us z was 3. And then we came up here and plugged that in and figured out y, and then we plugged those in and figured out x. That isn't what happened this time. All right, what else? Let's go, come on. Wait. Let's go, Kylie.
So that's just your final answer.
So that's your answer.
Right.
All right, George, is your hand up? Scratching your head, okay. Tess? I can't hear you, what?
Do you only do your answer like that when you have x equals z?
Yes. Otherwise, your answer looks like this,
Oh.
right? Yeah. Zoe?
Can you do 12 right here?
12 solve using the inverse method. This is a by hand problem. So remember, whether you're doing it on the calculator or by hand, the answer is going to be found by taking the inverse of the coefficients times the constants. So it doesn't matter how big your system is, that's how you get your answer. Now, 2 by 2s you need to be able to do by hand. Anything bigger than that you'll do on your calculator. But what are my coefficients? In the problem, make sure they're lined up. The coefficients are 3, 2, and negative 4, 1. So I'm going to need to find the inverse of that. And then I'm going to multiply that times 9, 4. Now, I'm doing this by hand, so I need to find the inverse. How do I find the inverse of a little 2 by 2? I got to switch these guys and change the signs on the other two, right? And then what? That is not it. Do not stop there. What else? Divide by the determinant. So what's my determinant? My head is exploding.
Two is 11.
It's 11. The determinant is 11. Oh, you guys, you've got to be able to find the determinant of a 2 by 2 because it happens in a lot of things. So 3 minus negative 8, that's 11. So each of these numbers is going to get divided by 11. That's the inverse. Now I got to take that and times it by 9, 4. This is a 2 by 2. This is a 2 by 1. So when I multiply, I will get another 2 by 1. And that's going to be my x and y. That's going to be the answer to the question. So, row times column. Do not freak out about the fractions. You have a common denominator. So this is 9 elevenths. This is 16 elevenths.
So 25.
So 25 elevenths. And then use these. Negative 18 plus 12. Negative 6 elevenths. And that's the answer to the problem. If you took your original system and did elimination on it, that's what you get. That's your answer. X, Y. Okay? Now, if I'm doing this on my calculator, then I put in this matrix, and I do A inverse times B. And that will give me the answer on the calculator. Okay, so what else? Yeah, Lily?
I don't know if I'm allowed to ask about this, but the 7-5 homework.
Yeah, you can ask about anything you want.
Like the maximizing profit one.
7-5 homework. We didn't do this? We didn't do this already? Okay, here we go. Here we go. So, the chart, is not set up for us, right? I've written on mine so I can't tell. It's not, right? It's not filled in. So we gotta fill it in ourselves. What did I tell you the other day? What's gonna go at the top of the chart?
X and Y.
Well, what I'm looking for. So what am I looking for? How many units of each food substance? So that's food A and food B. And what am I doing? I'm doing carbohydrates and proteins and cost.
Then you're on the wrong. Shut up.
I think she she's on the.
Oh, I'm on the wrong homework. I'm on the wrong homework. I grabbed the wrong one. That's why it looked familiar. I thought, I have done this problem before. No, we are doing, your 7-5 homework. And the chart is set up for you, right? Nope, okay, I can't tell from my writing.
The second one.
2.
Flip the page.
On the back.
Oh, we're doing the back side. All right, now I've got to figure it out. Here we go. So what am I looking for? How many of each unit should be produced? So the units are product A and product B. So I'm gonna put my A and B back up there. Now, what am I trying to do? This is gonna be profit. Oh wait, I need, how many rows do I need? So I need to know my profit. They tell me my profit is 225 and 2. Demand information requires that the total number of units produced be no more than 3,000. So total units can't be more than 3,000. The number of units of product B has to be greater than or equal to half the number of product A. So I don't know, I'm gonna let X be the number of A's, does that make sense? And Y will be the number of B's. So the number, so be X and Y, so X and Y together have to be less than or equal to 3,000, is that true? Can that be one of my constraints? And then the, did that already. The number of B, which will be Y, has to be greater than or equal to half of X. Would you agree with that? Now, no one grades your chart. I'm not putting that in my chart. I'm not sure how to set that up in my chart, but that's a constraint. Would you agree with me? That is a constraint of the problem. So if you can figure out a way to put that in there, that's okay. I'm not going to because I can't figure out a way to do it. And then what else? Well, X and Y have to be positive. Is there anything else I'm missing in there in terms of numbers? I think I've got it all. All right, what am I trying to maximize? Profit. So my maximum profit, or my profit, which I'm trying to maximize, will be found by 225x plus 2y. Agreed? All right, let's wrap it, see what it looks like. Should I use tens as my scale maybe? Or maybe more than that. Yeah, tens would be too big, let's use hundreds. Even that's kind of big, isn't it? Okay, so 1, 2, 3, 4, 5, 6. Yeah, I like 500. So if I use 500 as my scale, 1, 2, 3, 4, 5, 6. Here's 3,000. And 1, 2, 3, 4, 5. Here's 3,000. So that's my black equation right there. And where is my black equation shaded?
Down.
Underneath. So I'm focusing all my energy right here on this triangle, right here. All right, now I need to do this one. Now this one's gonna be a little harder to graph with intercepts because if you let either one of them be 0, the other one is also going to be 0. That line is, I'll do it in purple, that line is coming out of the origin, isn't it? So what do I know about that line? I can't do it with intercepts, I'm gonna have to do it with slope. What do I know about it?
Up 1 over 2.
It's up 1 over 2. So it doesn't matter what my scale is, I'm going up 1 block and over 2, up 1 block and over 2, and this is that line. It's a nice solid line, and where is it going to be shaded? Above? So now I am looking at, below my black, above my purple, I am looking at a region bounded by those 3 points. Would you agree with that? Now, 2 of those points I know, 0, 3000, and 0, 0. Those 2 I know already. This one I need to find. It is the intersection of my black and purple. So x plus y equals 3000, and y equals 1/2 x. Those are my 2 lines. Now, normally I eliminate everything, but this one's set up perfectly for substitution. So x plus 1/2 x equals 3000. So 3/2 x equals 3000. I'll multiply by 2/3. It looks like the x coordinate of that point is 2000. And if the x is 2000, the y will be 1000. So what do I do now?
Plug them in.
I take each of those 3 and plug them in right here, right? And I'm looking for the biggest one. So I will leave that to you, you can do that. Clearly it's not this. This says if you don't make anything, you don't make any money, obviously, right? So you can do that and figure out what the answer is. Okay, all right, what else? What else do we need to look at? Karen?
How did you get the purple line?
I graphed this right here. Y equals 1/2 x. Starts at the origin, has a slope of 1/2 of 1 over 2. Sammy?
How do you know that it's only the vertices that could be the maximum?
Because that's the way linear programming
Okay.
works. Yep, that's the way it works. Maximum or minimum. Yep, okay. Now, in the minimum, in some of the minimum problems we've done are shaded area. You know, we've had things that, I don't know, I'm kind of making this up, but we've had maybe like this. Things that look kind of like this. All this was shaded out here. Clearly that problem has no maximum, because you can keep going forever and ever, but the minimum is going to be one of these key points right here. This one has a maximum and a minimum. That's your minimum right there. Don't make any money, don't make any money. Okay, who else? Let's go. We got 20 more minutes. Let's go. Josh.
5A on the review.
Review 5A. We're finding the partial fractions. All right. What's our strategy to these partial fractions? You aren't going to have time to sit there and stew. You're going to have to know what to do. What do we do first when we have a partial fraction problem? Factor the denominator. Not the numerator, if it factors on it, but just the denominator. So, looks like my factors are 2x plus 3 minus 1. I'm going to double check that. Some of you factored wrong on your quiz, and guess what happens? If you factor wrong, you're wrong. So you got to make sure you factor correctly. Foil it out. I think I'm right. Okay. Now what? I got it factored. Now what? I set up my 2 separate fractions, which are 2x minus 1 and x plus 3. And A and B, or whatever you want to call them. Multiply through by the denominator. So I write it down. You don't have to, but I want you to understand that this is what you're doing. You're getting rid of your denominators. You have to multiply everything by the same thing, but different stuff is going to cancel out. So I'm going to have AX plus 3A and 2BX minus B, right? And then what? 1 equals A plus 2B. And 17 equals 3A minus B. And then you're on your own. Solve that somehow. This will probably be a no calculator problem, so you'll, I don't know, substitute, eliminate, Kramer's rule, whatever, inverse method, you could do what we did before if you wanted to. So you know what I'm gonna do? I'm gonna times this by 2. So 1 equals A plus 2B, and 34 equals 6A minus 2B. So it looks like my A is 5. And if my A is 5, my B is -2? Yeah. So my answer, your answer is 5 over 2x minus 1 minus 2 over x plus 3. That's the answer to the question. Those are the partial fractions. Okay, Josh? Now, a couple of little technicalities. What if you had what if that had been squared down there? Then you would have a third factor, or a third thing, that was x plus 3 squared, right? What if you had a situation where you have, I mean, this is the most basic, the one we just did. You can have two weird things happen. One is you can have a squared, which means you have to have a squared denominator. And the other thing that can happen, you might recall, is that we had, I don't know what the numerator is, but we had something like this in our denominator. Right? Now, that does not break down anymore. Okay? So you have a factor with an x, and you have a factor with x squared plus x plus 5. This numerator would be a, just like it always is. But remember, if that denominator is a non-reducible quadratic, then your numerator has to be linear. So your numerator would be bx plus c, remember? If you don't, go back to your notes, because we had one of those in our notes. It's all going to work out the same way, but since there are 3 variables, same thing will happen here. You're going to have 3 equations. Instead of just 2, I erased them, but instead of just 2 to solve, you're going to have 3, because you got those 3 variables. All right? So go back and look at your notes if you're wondering about that. Those are the 2 weird things that can happen in one of these kinds of problems. All right, what else? Let's go. Thank you. Pick her up. All right, what else? Sammy?
We do 9 on the review.
9 on the review, solve using Kramer's rule. All right, so again, you're not going to have time to ponder. You're going to have to know how to do Kramer's rule. So, what do I do when I've got this problem that looks just like the one that's inverse, just like the one I eliminated, that they all look the same, but it says Kramer's rule? What am I going to do? I'm going to do 3 determinants. The first determinant I'm going to do is these guys right here, 2, 9, negative 3, 1. These are the x's and the y's. This is called the coefficient determinant. All right, let's see if we can get this right. What is the value of that determinant? 29. A plus 29. That number, here's my answer, like 5, 2. But this time they're going to be fractions, and the denominator of those fractions is 29. Remember when I did the inverse problem and my answers came out something 11s, something 11s? That's what's going to happen here, only it's 29s. So now I need the numerators. So the numerators are going to be 2 more determinants. And I find them by taking these numbers right here, the constants, and pasting them on top of whatever letter I'm solving for. So if I'm looking for X, I'm going to put 7, -1 here, and then that stays. And if I'm solving for Y, I put 7, -1 here, and that stays. Now notice, there's no switching of any order. Nothing changes. You are literally cutting and pasting on top of whichever one you need to look for.
I'm sorry, I was almost.
Oh, it's okay, you're not in trouble.
Thank you.
Yeah, I always scream at them. I'm glad you found us, good. Okay, what's the value of this determinant?
24.
Oh, wait,
10.
4.
4. Guys, oh my gosh. 7, 3 minus. So that's 4, that's your X. And then what's your Y? Please, let's get it right. What's our Y?
-65.
-65. Now, sometimes those reduce, like in every single problem, if you can reduce, reduce. We can't, so we're done. Kramer's rule. All right, Lucy?
Is there gonna be, it's not on the sheet, but is there gonna be a problem where you can find the area using the determinant? Or I guess you can use whatever you want. But you can find the area of whatever you use.
Oh, there might be.
Okay.
We just practiced that for our quiz. Do you know how to do it?
Can we practice one?
Yeah, make up 3 points for me.
Okay. 3, 4.
Actually, Lucy, what's your middle name?
Jacqueline.
All right.
Oh, am I still making the points?
Yeah.
Okay. -1, 7, and 2, 6.
All right, there they are. There are the points. These 3 points make a triangle. We're gonna find the area of triangle LJM. Okay? Now, if this is a no calculator problem, then yeah, I would do determinants. And in fact, I would do that anyway, because that's certainly the fastest way, and there are a lot of problems on this test when I get through it. So, if I'm gonna use determinants, what's the first thing I need to do? Make 2 vectors, and I don't even need to draw the triangle. I'll use L. So if my 2 triangles would be LJ, and, or my 2 vectors would be LJ and LM. If I start with L, don't have to start with L, but that's where I start. So from L to J, if it helps you to put them in the picture, that's fine, but you certainly do not need to. We're going from L to J, so what's happening? We're going -4 and 3. And then from L to M, we're going -1 and 2. Now, we leave them just like they are, and we make our little determinant. Okay, let's get it right. What's our determinant? -5. Because it's -8, -3 minus, so it'll be -5. And then don't forget to divide by 2. And you ignore the negative, because if we had done these vectors in the opposite order, which would be perfectly okay, it would have come out positive. So we just ignore the negative, so the area is 2.5. Okay? Easy. Yep, good, like that. All right, what else? Homework, quizzes, review sheet, Zoe? 11. G. Who remembers what that means? First of all, where's the matrix today? Okay. Who remembers what it means? Let me put a little TR out in front of it. It means find the trace. And when I do the trace, the only numbers that matter are the ones on what we call the main diagonal. The matrix must be square. This one is. So there's my main diagonal. I add them up. The answer is -1. That's it. That's all there is to it. Add them up. However many there are, has to be squared.
For 50, it just says vocab. Do we just have to be aware of it, or is it gonna be there a definition where you to write?
Could be, but like this problem right here, you needed to know your vocabulary here because you couldn't do the problem unless you knew what that meant. and then what to do with that. So I need you to just know your matrix vocabulary. Okay, so that when I say use Gaussian elimination, you know what that means. You know what you're supposed to do. All right, what else?
11L.
11L,
Is that just down 2 and over 3?
it means go to matrix D.
Yep.
And find the entry that is in the second row, third column. So the number that is in the second row, third column of matrix
4.
D is 4. The answer is 4. That's all that means. Lucy?
Can you do 11H?
11H. All right, what does that notation mean? That means transpose. And what does it mean to transpose a matrix?
Flip rows and columns.
Whatever was a row becomes a column. So when I look at matrix B, and it says B transpose, when you, I don't know how you write your matrices, but I always write mine, I write the rows. So instead of writing 1, 2, 3, I will write 1, 2, 3. Row 1 is now column 1, and row 2 is now column 2. That's it. So the original matrix was 2 by 3. The transpose obviously will be 3 by 2. Yeah, it all always makes sense.
Can you do 11P?
11 what?
11P.
P? He did it already.
Oh, you
It's
did?
in a video.
Okay.
Yep. Yep.
Can you explain again, like, the identity things, like how you, like, know which ones are, like, the x-axis? and, like,
Well,
the y-axis?
if you think of the identity matrix, right? This is like, it's actually I, vector I, but it's like X, because it says go over 1 and up 0. That is vector X, or vector I. This is your Y, literally it's J, but it's your Y, it's on your Y axis. So this is this changes nothing. This leaves X right where it's at, and it leaves Y right where it's at. If you put a negative here, basically what you're doing is changing the sign on X. Well, think about your coordinate axis system. If you have a point right here, doesn't matter what it is, let's call it 2, 3. If you change the sign on X, it becomes negative 2, 3. So what have you done? You've reflected across the y-axis. That's what happens when you change the sign on X. So this would reflect you across the y-axis. Obviously, if you do this, it's going to change the sign on Y, which is going to reflect you across the x-axis. If you do both of them, think about what that does. Here's your point. Here's your point, 2, 3. If you change the sign on both, where is that point now? Across the origin. When you rewrite your matrix like this, like sort of backwards, you've taken what used to be X, that used to be X, but now it's Y. It used to be Y, but now it's X. So what have you done? You've reflected across the identity. You've switched your Y to your X. Okay? All right. Yep, Tess?
Should you do 11M?
11M. No, I can't. Why can't I?
Square.
It's not square. And if your matrix isn't square, it does not have an inverse, it does not have a determinant, and it does not have a trace. So if you are asked for any of those things on a matrix that isn't square, the answer is can't do. There are things in matrix land that you can't do. So if you get a empty set can't do, it's fine. Right? All right, one more. Time for one more. Let's go. H. I just did that.
That's the transpose.
Oh, sorry, I have it written. It's just like a misspelling.
All right, our test is Thursday. And kids, you have got to practice this